Welcome to Cambridge Chemistry channel. Be sure to like the video and subscribe. It really helps the channel to grow. Today we will discuss some tricky questions of chemical energetics. This is part 2. So I have uploaded part 1 later. So this is part 2. Nitric oxide and let's start. Nitric oxide and bromine vapor react together according to the following equation. Nitric oxide plus bromine to form NOBr. So this is exothermic reaction. The reaction has an activation energy is positive, and you know that the activation energy for both exothermic and endothermic reaction is always positive. What is the correct reaction pathway diagram for this reaction? Let's change the color. So this is so first identify that the which profile diagram is exothermic. So all profile diagrams are exothermic. Now then identify the errors in the diagrams. This is activation energy. So this is wrong, labeled activation energy, because for this reaction activation energy is this. So that's why this is correct. Incorrect option. Enthalpy change is correct, but activation energy is incorrect. So next question, look at the next option. So these are the two questions. So next option, activation energy labeled correct, but delta H labeled incorrect, because enthalpy change will be from reactant to products. So arrow should be like this. So this is wrong. So C option. For exothermic, for this exothermic reaction, activation energy labeled correct, but enthalpy change labeled incorrect, because for exothermic reaction arrow always we should draw arrow down, not like this. So this should be direction of should be like this. So delta H always. So D option is correct, because activation energy labeled correct and enthalpy change from reactant to products. So this D option is correct. Next question is, all reactants and products of an exothermic reactions are gaseous. Which statement about this reaction is correct? The total bond energy of the product is less. This is exothermic reaction. So let's underline this. The total bond energy of the product is less than the total bond energy of the reactants, and delta H for the reaction is negative. Delta H for the reaction, this part of this option is correct. Delta H is negative for exothermic, but the total bond energy of product is less than this is incorrect, because total bond energy of the product is more than the total bond energy of the reactant. So that's why this option will be incorrect. The total bond energy, now let's discuss the B option. The total bond energy of product is less. This is also incorrect. And then the total bond energy of the reactant, delta H for the reaction. So delta H is also incorrect, and product is more than the total bond energy of the reactant. C option, the total bond energy of the product is more. This is correct. Then the bond energy of the reactant, because look at the diagram. This is the bond energy of the product. So total bond energy is more than the total bond energy of the product is more than the reactants. So this is correct option. Is more than the total bond energy of the reactant, and delta H for this reaction is negative because exothermic reaction, and delta H for these reaction is negative. This is correct. So C option is correct. The total bond energy of the product is more than the total bond energy of the reactant, and delta H for the reaction is positive. Incorrect. Product is, this is, so C option is correct option. Next question, question number 3 for so question number 3 for which equation is enthalpy change correctly described as an enthalpy change of formation? We know that the enthalpy change of formation is defined as, it is enthalpy change delta HF, it is enthalpy change when 1 mole of substance is formed from its constituent elements. Under standard conditions, in their standard states. So look at the option. So reactants, on reactant side there should be only elements. So over here nitrogen monoxide to form nitrogen and oxygen, so this is incorrect. Carbon monoxide also again compounds on reactant side, so this is also incorrect. H2NaCl, so this is also incorrect. So D option is correct because on reactant side only elements are there, or this is potassium magnate, and this can be because oxygen is there. Oxygen is element, manganese is element, and potassium is element. So enthalpy change 1 mole, and 1 mole of substance is formed from its constituent elements. This option justify the enthalpy change of formation. So D option is correct. So let's start question number 4. Given sulfur plus oxygen to form sulfur dioxide, delta HF is minus 297 kilojoule per mole, and sulfur plus 1.5 oxygen to form sulfur trioxide. What is the enthalpy change of reaction delta H of delta H reaction of sulfur dioxide plus oxygen to form sulfur trioxide. So for this reaction, for this question, we have to arrange chemical equations. So this is actually chemical reaction. Let's erase this. So first draw a triangle, which I have discussed in class. Sulfur, this is chemical equation. 2 sulfur dioxide plus oxygen to form 2SO3. So we have to find out delta HR, enthalpy change of reaction. Now this is two boxes, reactant boxes, and this is product boxes, and write down elements on third box. Sulfur plus oxygen. So you know that sulfur plus oxygen, enthalpy change of formation is given. Sulfur dioxide is formed. So let's draw with another arrow, another color. So this is sulfur dioxide formation, and delta HF of sulfur dioxide is minus because 2 over there, so 2 into minus 297. Now sulfur trioxide is formed accordingly, sulfur plus 1.5. So we can write down over here 1.5 oxygen. So let's draw with another arrow. So enthalpy change of this reaction is, we are using this sulfur and this oxygen. Okay, so the delta HF for this reaction is minus 395. So this is the starting point. This is starting point. And you know that we have to form this product. So the starting with one arrow, and other route is like this. This is another route. So we know that we have discussed in class that route 1, this is route 1, or this is route 2. So we know that 2 minus 297 plus delta HR is equal to minus 395. 2 into 395, sorry, because 2 moles of sulfur trioxide is formed. So 2 into minus 395. So this is equal to delta HR is equal to minus 196 kilojoule mole inverse 1. Hope you will understand this question. Mole inverse 1. So the option A is correct option. Next question, question number 5. The table shows the enthalpy change of neutralization per mole of water formed. Delta H for this reaction. For reaction of for acids and bases. Acid, hydrochloric acid, base, sodium hydroxide is, I have discussed in class that the enthalpy change of neutralization of strong acid and strong alkali is minus 57 kilojoule per mole always. So this is P, and sodium hydroxide, this is minus 54. So hydrochloric acid Q is minus 52. This is for strong acid and strong alkali, and this is strong acid versus strong base. And P, sodium hydroxide, if it is minus 54 less than 57, it means over here weak acid is there. P is weak acid, so P should be weak acid. Because it is less than 57. Hydrochloric acid and Q, it is minus 52, so Q should be weak alkali. Nitric acid and R, 57, so R could be strong alkali, strong base. Now what are P, Q and R? P, Q should be weak alkali, and R should be strong base, R should be strong base, and P should be weak acid. This is weak acid, and this is weak alkali or weak base. This is strong base. What are P, Q and R? P is ethanoic acid, this is correct. Q is ammonia, is a weak alkali, so this is also correct. Potassium hydroxide is a strong base, so this is also correct. So A option is correct. Let's check the other options. Ethanoic acid is correct. Sodium hydroxide is strong base, so it is incorrect. Ammonia is weak base, so this option is incorrect. Sulfuric acid is strong base, so this is incorrect. Ammonia is weak alkali, it is correct. Potassium hydroxide is strong base, but one option is P is incorrect, so this is also incorrect option. Sulfuric acid again strong, sodium hydroxide V a strong base, so it is incorrect. Ammonia is, so it is also incorrect. So A option is correct. Next question, which equation represents the standard enthalpy change of atomization of bromine? Represents the standard enthalpy change of atomization. We know that atomization is 1 mole of gaseous atom is formed from its elements in their standard states under standard conditions. And 1 mole should be 1 mole. So A option, there is 2 moles of bromine gas, so this is incorrect. Br2 gas, so bromine state symbol is not correct. 2Br gaseous state, gaseous atom, but the state symbol of bromine is incorrect. C option, half Br2, state symbol is correct. Half Br2, there is 1 mole of bromine gaseous atom is formed. So this option is correct option. Half Br2 gas, state symbol again incorrect, and bromine is 1 mole of bromine, but state symbol of bromine in their standard states, because atomization, enthalpy change of atomization can be defined as 1 mole of gaseous atom formed under standard conditions in their standard states. In their standard states. So this option justify all these conditions. 1 mole of gaseous atom formed from elements under standard conditions in their standard states. C option is correct. Question number 7. Propanol has the molecular formula C3H6O. Enthalpy change of combustion of hydrogen is 2 minus 286 kilojoule mole inverse 1. The enthalpy change of combustion of carbon is 3 minus 394 kilojoule mole inverse 1. The enthalpy change of combustion of propanol is minus 1786 kilojoule mole inverse 1. Using this information, what is the enthalpy change of formation of propanol? So again draw Hess cycle. Propanol C3H6O carbon, 3 carbon, H2 plus oxygen. CO2 plus water. So these are 3 triangles. Enthalpy change of combustion is of carbon is given. Enthalpy change of water is given, and this is propanol. So this is equal to minus 1786. This is equal to 3 into water hydrogen is minus 286, and this is equal to 3 into carbon minus 394. Now we know that this is carbon dioxide and water is formed. Draw two cycles. Enthalpy change. What is enthalpy change of formation of propanone? So draw two cycles. One is like this, and other is like this. So this is delta HF. So write down accordingly. 3 minus 394 plus 3 minus 286 is equal to delta HF minus 1786. So when we solve this equation, we can get delta HF is equal to minus 254 kilojoule mole in verse 1. So C option is correct. Next question is use of the data booklet. Use of data booklet is relevant to this question. A student makes 25 centimeter cube of 0.10 mole per dm cube sodium hydroxide solution with 25 centimeter cube of 0.1 mole per dm cube hydrochloric acid and noted a temperature rise of 2.5 degrees centigrade. Okay, 25 of sodium hydroxide, and what is the enthalpy change of the reaction per mole of sodium hydroxide? This is chemical reaction to form NaCl plus water. Energy released Q is equal to mc delta T. (25 plus 25 centimeter cube is equal to 50 centimeter cube. So this is the volume, total volume, and total volume is equal to mass minus 50. Specific heat capacity is 4.18 or 4.2, you can take, into 2.5. So the answer is 522.2. Now Q, unit of Q is joule, And the enthalpy change for this reaction delta H unit is, enthalpy change unit is kilojoule per mole. So convert it into kilojoule first, divided by 1000. This is equal to 0.5222. So the mole of 25, so this is now heat released is kilojoule. Now we know that enthalpy change of reaction is equal to Q over N. N is the number of how. So this is the, what are the moles? Sodium hydroxide 25. So let's calculate the moles. N is equal to 25 concentration into volume into 0.10, because both moles are same, sodium hydroxide, and ratio is 1:1. So the mole would be N is equal to 0.0025. So let's check. 25 divided by 1000 is equal to into 0.1. So this is equal to 0.0025. Now enthalpy change of reaction is equal to 0.522 divided by 0.0025. This is equal to delta HR is equal to minus 20209 kilojoule mole inverse 1. So option A is correct. Which energy change corresponds to the enthalpy change of atomization of hydrogen at 298 Kelvin? The bond energy, as we have discussed in the class, that the enthalpy change of atomization of diatomic element. This is very important point to note down. Enthalpy change of atomization of diatomic molecule is half of its bond energy. So very important point to learn. The bond energy of HH at bond, half of the bond energy of the HH bond. This is correct option. The minus half the bond energy, this is incorrect. Minus the bond energy of HH bond, this is incorrect. Question number 10. We have discussed this question in class, so let's calculate this question. TiO2 solid plus 2C solid to form Ti element plus oxygen plus carbon. Standard enthalpy change of formation of TiO2 and carbon monoxide are minus 940 and minus 110 kilojoule mole inverse 1 respectively. So this is minus 940 and this is carbon monoxide is minus 110. So this is 2 into minus 110. Element to element 0, and this is carbon to carbon is also 0 because enthalpy change of formation of element is 0. Now draw the root. Use another pen. Draw the root. This is starting point. Elements are starting point. Starting. And this is ending. We have to find out delta H. So one arrow start from here to this point ending, and other arrow is so this directly root 1 and root 2. So equalize the root 1 and root 2. Minus 940 plus delta HR is equal to minus 110. 2 into minus 110. Now after calculating we have delta HR is equal to plus 720 kilojoule mole inverse 1. The other question number 11. Question number 11. Hydrogen peroxide slowly decompose into water and oxygen. The enthalpy change of reaction can be calculated using standard enthalpy change of formation. H2O2, H2O, and draw another cycle. H2O2 liquid and oxygen gas. Hydrogen plus O2. Hydrogen peroxide is enthalpy change of reaction. We have to find out. Enthalpy change of formation of hydrogen peroxide is minus 2 into minus 187.8, and water is minus 285.8 kilojoule mole inverse 1. So this is starting point and this is ending. Draw the cycle, draw the root. And one root is this. This is one root, this is 2. And equalize this root. 2 into minus 87.8 plus delta HR is equal to minus 285.8. The answer is delta HR of this reaction is minus 196 kilojoule. So we have discussed this question earlier. Please follow that question. Question number 13. The standard enthalpy change of combustion of glucose and ethanol are given as minus 2820 and minus 13. This is enthalpy change of combustion. So this is one box, this is another box, and this is delta HR, enthalpy change of reaction we have to find out. And draw another box for elements plus hydrogen plus oxygen. Enthalpy change of combustion of glucose. Sorry, over here combustion product carbon dioxide, because enthalpy change of combustion is given. Water. Enthalpy change of combustion of glucose is minus 2820, and enthalpy change of ethanol is 2 into minus 1368 kilojoule. Draw two roots. This is from here to here. This is here. And calculate accordingly enthalpy change of reaction. Root 1 and root 2 minus 2820 is equal to delta HR plus 2 into minus 1368. and delta HR for this reaction is equal to delta HR for this reaction is equal to minus 84 kilojoule Question number 14. The diagram shows a reaction pathway for an endothermic reaction. Which row represents the activation energy? Which row represents the activation energy for the forward reaction? So this is B. This is activation energy from reactant to product. This is for reverse reaction. This activation energy for reverse reaction. But this is for forward reaction. Because this pathway for an endothermic reaction. And this is enthalpy change, not like this, can be, this is enthalpy change. So this is activation energy. Question number 15. A student mixed 25 centimeter cube of 0.35 sodium hydroxide reaction, 25 centimeter cube of 350 mole DM inverse cube hydrochloric acid. The temperature rose by 2.50 degrees centigrade. Assume that heat to the surrounding, heat released to the surrounding. The final mixture had a specific heat capacity 4.20 joule. So first heat released is equal to mc delta T. M is total mass 25 plus 25, volume is equal to mass, that is 50. Specific heat capacity is given 4.20 into temperature rose by 2.50. Excuse me. So this is equal to 0.5, sorry, 52 minus, and mc delta T is minus. This is equal to minus 52.5. This is joule. Now convert into kilojoule. 52.5 divided by 1000. So this is equal to 0.525. And enthalpy change, and calculate the number of moles, like mole is equal to 25/1000 into 0.350, which is equal to 0.00575. And enthalpy change of this reaction is minus Q over N. Q is 0.525 divided by mole is 0.00575. which is equal to enthalpy change of reaction is equal to neutralization is equal to minus 60 kilojoule. Kilojoule per mole. Question number 16. Enthalpy changes that are difficult to measure directly can often be determined using Hess law to construct an enthalpy cycle, which enthalpy change is indicated by X in the enthalpy cycle shown. These are elements, these are compound. So only difference is in this cycle that the elements drawn above, while compounds, products which are formed from the compound drawn below, and the same pattern is followed, like delta HF hydrogen, this is delta H of F over here carbon, and this is delta HF of carbon dioxide, and this is delta HC, delta H of water. So enthalpy change of -4 into enthalpy change of combustion of hydrogen. Hydrogen over here is 2 moles of water is formed from 2 moles of hydrogen. So this is not correct. Enthalpy change of combustion, not combustion. Enthalpy change of formation should be there, or combustion can also be. So this is not correct. 4 into enthalpy change of combustion of hydrogen is not correct, because this is formation, and question is which enthalpy change is indicated X. So this is water, 2 moles of water is formed. So plus 4 into enthalpy change of combustion, not correct, not correct. Minus 2 into enthalpy change of formation of enthalpy change of water. Enthalpy change of combustion is not positive. So this is also incorrect, and 4 moles are also incorrect. Minus 2 into enthalpy change of formation of water. So minus enthalpy change of formation is correct, but enthalpy change of formation is positive. So this is sign is incorrect. So 3 options are incorrect. D option is correct option. So this is plus 2 into enthalpy change of formation of water, that is equivalent to X. The reaction pathway diagram is shown. Which enthalpy change could the diagram not apply to? This is energy profile diagram for exothermic reaction. So which enthalpy change of atomization can be, because not, this is enthalpy change of atomization is always positive. So this is correct option, but enthalpy change is endothermic. And this profile diagram for exothermic. Enthalpy change of combustion is there. Enthalpy change of formation can be negative. Enthalpy change of neutralization also exothermic. So which enthalpy change could the diagram not apply to? So this is for enthalpy change of atomization. Given the following enthalpy changes, I2 gas, 3Cl2 chlorine to form ICl3 iodine trichloride, and delta H for this reaction is minus 214 kilojoule, and enthalpy change of this reaction is I2 solid into I2 gas is plus 38. What is the standard enthalpy change of formation of iodine trichloride? Now let's draw the pathway. This is gas, but under standard conditions it should be solid. So let's iodine solid plus 3 over 2 Cl2 to form 2 ICl3. Iodine in gaseous state plus 3 over 2 chlorine Cl2. This is over here, delta HF we have to find out. So delta H of 1 mole of ICl3, but over here 2 moles of ICl3. This is gas. So gaseous atom. This is half gaseous atom. One mole of gaseous atom. So this is plus 32, and we know that this is half of its bond energy. 38 divided by 2. Now so this is for 2 moles, and this reaction is 2 moles, and we have to find out 1 mole of trichloride. So this can be divided by 2, minus 214 divided by 2. What is the initial point is this. And final point is this. So delta HF is equal to, in this way, delta HF is equal to 38 over 2 plus minus 214 over 2. The answer is delta HF of this reaction is enthalpy change of formation of 1 mole of iodine trichloride is B, minus 88 kilojoule per mole. Next question is which statement about the standard enthalpy change. Question number 22, which statement about the standard enthalpy change of formation of carbon dioxide is correct? Is it is equal to the standard enthalpy change of combustion? Yes, we have discussed so many times that enthalpy change of combustion and formation of carbon dioxide and water is equal, because oxygen to form CO2, this is enthalpy change of combustion as well as enthalpy change of formation, because 1 mole from its constituent elements and 1 mole of substance is burned in the presence of excess oxygen to form carbon dioxide. So this is correct option. Let's check another option. It is equal to twice the bond of energy. No, this is not correct. It is the energy released when 1 mole of carbon dioxide is formed from carbon temperature at standard temperature of combustion of the carbon. No, this is also not correct. It is the same for carbon dioxide produced from graphite and diamond. Graphite and from diamond. No, this is also incorrect, not same. So A option, it is equal to the standard enthalpy change of combustion of carbon. Enthalpy change of formation of carbon dioxide is equal to the enthalpy change of combustion. So next question, gaseous phosphorus pentachloride can be decomposed into gaseous phosphorus trichloride and chlorine by heating. The table gives the bond energies. So the reaction is PCl5 to form PCl3 plus Cl2. So PCl5 bond energy, and we know delta HR is equal to bond energy of reactants minus bond energy of product. Bond energy of reactant is equal to PCl5 5 into 330 minus reactant minus product, PCl3 3 into 330 plus 2 into chlorine Cl2 240 plus 240, it is equal to delta HR is equal to plus 420 kilojoule mole inverse 1. D option is